So we're going to have Kristian and Eric, who are going to be presenting us how we can develop very fast on NSO. Typically, when I go to customer says, your first project going to take 1 year, I'm very happy that after this presentation, I can go and change my pitch. It's going to take you 6 months. So thank you very much, and have a great session.
Thank you.
Here's the power.
Wow. So I think it's Eric and Kristian presenting.
Yes.
I'm going to stand over here in the sort of the background.
Hi, my name is Erik Löwgren, and I'm the head of network at GleSYS. Together with Kristian from Centor, I will talk about how we managed to go from nothing to API provisioned network services in 6 months. And you only worked half time, right?
Yeah, something like that. Part-time, yeah.
We'll cover the mandatory company presentation, our motivations for choosing NSO, how this thing called RESPNET makes your life a little bit easier, and finally, how we gain the courage to go into production. So we are a Swedish infrastructure provider. We're headquartered in the beautiful town of Falkenberg, about 1 hour south of Gothenburg on the west coast of Sweden. We run 5 wholly owned data centers in Falkenberg and Stockholm in Sweden, and Oulu in Finland. We also run a network, of course, connecting our data centers and third-party sites. We provide virtual and physical compute resources, as well as space for your own hardware, which together with our connectivity and professional services delivers a one-stop shop for all your hosting needs. We focus on 3 distinct areas to differentiate ourselves in the market. As we build the infrastructure at scale from the ground up, we can control both cost and quality, and our dedicated and co-location offerings is fundamental to our cost-effective hybrid cloud offering. And compliance is quickly becoming more critical than ever, and with European ownership, data locality in the Nordics, and ISO certifications, we are very well set to deliver on customer demands in this area. And as we are firmly planted in the Nordics, our energy mix here, together with our heat recovery in our data centers, provides the lowest possible CO2 footprint globally. While we are primarily a hosting provider, we also run a decent-sized service provider network in order to deliver our connectivity services. This is the initial scope of our NSO deployment, and the data center networking is coming later. 6 months ago, we had this network team, 4 amazing individuals and me. Together we cover all aspects of networking at GleSYS. We do everything from procurement and vendor relations to fieldwork, everything. So we got a new team member just right now, and he's really great. One of the fundamental arguments for our NSO journey is that we would like to keep this very tight and small team. And instead of writing configuration, the team can focus on architecture and service development and other more meaningful tasks. This means that we can keep this amazing team and still deliver on the company's growth targets in the coming years. And our investments into NSO already start to make sense when we just remove the labor of service provisioning from our engineers. But the stark difference in operational excellence when you move from the context of managing a device into managing your whole network is where the real value appears. We devised a concept called service access domains as a demarcation between our NSO managed and legacy managed network devices. This is simple like abstract domain where you terminate services with a access domain and a VLAN ID. This then has the notion of a primary and a secondary router, and all single home services for each access domain is provisioned on the primary router. But when you set the administrative state for the CFS service for the router of the primary router to maintenance, we reprovision all of the single home services to the secondary router. This is very easy to do when you have the context of your whole network in NSO, but it's inconceivable if you're doing this manually, right? So the impact is profound when you have an outage or a maintenance window on that primary router, and you can just move everything. It's like VMware. I've been very, very jealous about those guys that work for years. Just push a maintenance button and everything goes away, and they can do whatever they want. So now I have that as well. The other factor is that we want to allow our customers to order the network services through our self-service portal, just like they do with our compute resources. This is obviously something that requires API-based service provisioning, which is, of course, one of NSO's really strong points. Here you can see, I think, the NSO in Docker CI test machines.
Right, yep.
We all remember when the first time we set our eyes on this magical box, right? We envisioned the greatness of our finished automation project. I bet we all dreamt of building something like this, with tightly modeled customer-facing services describing every possible permutation of the services that we deliver to our customers. And how the constant headache of configuration drift caused by manual configuration swiftly is eliminated by replacing the keystrokes of the engineer with the consistency of a machine, right? Unfortunately, when you open the box up, it looks a lot like this. And there's going to be a lot of trial and error going into building your castle. Thankfully, there's now this thing called RESPNET, which is the realistic service provider network, which is an example service provider network automated with NSO. This provides answers to many of the fundamental questions that you would have opening this box for the first time about architecture and service design. And it's a bit equivalent of turning this box of random Lego bricks into an actual set, like with a manual on how to get from start to finish. And I think we can all agree that going from your safe, like the development environment into production is the most nerve-wracking part of the automation journey. I know that there is some actual technical stuff that Kristian will handle.
Yep. Right. So I guess just on the RESPNET bit, right? That's something we're gonna sort of come back to throughout the day here. I have a session later, and there are 2 other mastering service design sessions where we're gonna talk about that, right? But I think it's a really nice sort of jump start to your whole process, right, of how you do automation with NSO. But on to testing, right? So this is a CI pipeline. It's the one, it's from the GleSYS network environment, right? And we have a couple of different phases. So the first one is the build phase. This is just putting together a container image. It has NSO in there. You would put in service packages, net packages, and all of these things, right? Essentially what constitute the actual NSO that we're gonna run in the production network. Then we have a number of different tests, right? And I think this is quite cool. So test full netsim. I think you can all read what it says, right? So the top one, if you look at the test environments here, right? The top one is full netsim. And this means that we're using netsims. And full is referring to the fact that we're running more or less a full replica of the network. It's not like everything. We're not doing access switches and stuff like this. But if we look at the IP routers, IP and MPLS routers, pretty much everything you'll find in your ISI's database, those are the devices that we're gonna find in here as well. Then there's an equivalent, and you know netsims, right? They're very low on resources. So this is perfectly doable today, right? You have large machines and everything. But I think one of the cooler things is the next one, which is full XRD. So XRD is a containerized ISXR router, right? So unlike netsim, this one has a control plane. So when we configure this thing, we're actually going to get a running network. You can do show ISI as what are they called? Neighbors, not neighbors, the other ones, adjacencies, right? And actually sort of look at what your network looks like. Next we have a pip in XRD. This is a smaller environment actually. Great if you have a low-powered laptop. And after this we have service discovery. And once again, this is based on netsims. And so it's sort of similar in a way to the full netsim one in that we're doing a full-on replica of the network, but the difference here is the kind of tests that we do in this, right? So in the full net sim, we start with sort of CFS services, this very clean sort of intent going into the network, and we start with an empty network, right? And then we provision it, and we see what happens, right? We expect to get a working network in the end. With service discovery, we do it the other way around, sort of. We bring in the configuration from the production network, right? The full configuration from all those devices. We load that up in these net sims, and then we do the service discovery dance, right? So we find the services that are in the production network. We bring this up to sort of that CFS level where we have abstract intent, and then from there we can go down again and let our services now provision the network. And so we have this little procedure, a little dance. We'll get back to this as well in the second mastering service design session, if you're interested. There's also documentation on this stuff. But it's very cool because what we end up in the end is this sort of configuration coverage and diff check, where we can check what's in the network and what do we provision, right? And what is the difference between that? So that gives you a very sort of tractable process for figuring out what should I be doing, right? I mean, is my automation actually covering the stuff that I have in my network, or do I have more stuff that I need to take care of? Do I have stuff that I need to clean up? And finally, we do an upgrade full net sim. So this is a upgrade here refers to that we're doing a CDB schema upgrade, right? So we're like, this is one pipeline, right? And this could be running on a merge request. Probably not, because the deploy job over there has been run, but this could be running. The other jobs could be running on a merge request. And then in the upgrade job, what we would do is we take the NSO as the image, right, from the master branch, and then we start that. And then we start, after we've done that, we start the image built on this pipeline, right? And through doing that, we don't simulate. We're actually doing a CDB schema upgrade, right? There's a number of tests in there, right, to make sure, is the network working? We run self-tests on services. Are ISI's adjacencies up? Are they working? All of these kinds of things. Then we have the second phase after this, which are compare jobs. So what this does is, next to running various tests, we also check the actual full output of all the device configuration, right? And we compare this to an expected output. So these jobs are about sort of doing that check, and if there are differences, they will automatically open up merge requests. After this, we have a deliver, push to a container registry, and finally a deploy, which is just deploy. And here we have failures, right? So the test sort of went through, right? We reached a network that's working, but something has changed. Something has changed in the network, so we're now pushing new configuration. And since we're capturing that and comparing it to these expected output files, we're sort of seeing all those little differences, right? And that's what these jobs are failing, and that's what they're showing, right? So if we proceed, we're going to find, this is now zoomed in, right? But this is an merge request that the system is then automatically open, where we can look at those differences. And this is it's a little tricky. I mean, obviously you can see here, this is a diff, right? So left side is the old side, right side is the new side, and it's red and green. But it's actually a diff of a diff. So the base file here is already a diff, and that diff is produced between the production network and what NSO would provision. So if you look at the second column of minuses or pluses, right, that shows that our starting point in the old one, we were actually missing these lines. They were in the production network, but NSO would not configure them right. And through this merge request, what we're seeing is, well, they now match up, because in the second column that would be here, there are no plus or minuses, right? So in a diff, that means they're the same. So I think this is a very nice way of sort of grabbing and getting very good control over the whole thing. And by doing this for a full replica of the network, we get a lot of confidence, sort of, in knowing that we're writing working code.
Yes. We have talked about NSO and automation for a long time in our organization. And for you who know Kristian, he's been talking to me for a long time about
Netconf and Yang.
Yes. My first internal presentation mentioning Netconf and Yang is from 2017. And it turns out there's a lot of pieces to the automation puzzle, like proper Netconf and Yang support on the device. It's not a given today, but we're getting there. But back in 2017, we were still running 7600s.
Yep.
So that was a blocker. It's also very important to get management buy-in, because you're not going to do this just in the network team. It's going to affect many parts of your business, unless you run like an enterprise network or something, I presume. Then there's the thing with the two disciplines that collide here, like the software development discipline and the network engineering discipline. We have very good software developers and we have very good network engineers. But when you try to combine this, the network engineers are quite bad at writing code, and the software developers are really bad at managing networks. So this turns into a massive headache. Also, everyone has their own agenda and like their day job. So we actually started some like attempts at an NSO project, but they all like dissipated because we didn't have the time and focus to push through and to the bitter end. So when we were deciding to do our third push, we decided that we need external help, and we found this guy. And since he is both a software engineer and a network engineer, we just put him in a chair, gave him access to what he needed, and then he got to work. So, and with him having nothing else to do, it was very easy for him to focus. And everything that he needed, we made sure to expedite so that we didn't block him. So you did not too much time for drinking coffee, right?
Right. Yeah.
Which is the usual problem with these kind of projects, that you need to like clean up the network. Or so what we had a clearly defined scope, and we also had the Kristian, and we also managed to remove as many blockers as possible. For instance, we did the service discovery. Instead of cleaning up the network so that it's nice and pretty, that someone else had to do, that you would have to wait for, you did that by feature flags in the services and in the service discovery code. So I think that's our key takeaways. Yeah. That was everything I had to say. Thank you so much for listening.
All right. Thank you. Thank Eric and Kristian. That was a great presentation, a great testimonial. And again, 6 months, full network automation. We got our Slido if you got any questions. But again, 6 months. So what's next in your journey? What comes after full network automation?
So I think it's in production, right? Which is what we're counting here. And I mean, the initial use cases here we're doing is like network infrastructure, right? And there's a customer use case for like basically layer 3 VPNs.
Yes.
Right? But there's more. There are more services in the network. So there's a very natural continuation for that. Yes. So the service discovery that's done is based on, well, all these existing services that we're doing sort of in this first iteration, right?
All right.
There's
and
more.
You're going to be able to go using the same framework much faster for the next ones.
I think so. I think it gives you sort of that very nice way of working, right? It's very easy to sort of figure out what should I do next, right? Which NSO version do you run? 6.3.1, I think.
6.3.1.
Yep.
And then I think there was a question about brownfield and service discovery.
Yeah.
I think is there anything else you want to say about how you do the discovery? You mentioned you wrote something for discovery.
Yeah, I mean, we have this, Uras and I have this session on, these mastering service design sessions, and we're going to talk about doing service discovery and sort of brownfield. So, I mean, the plan, it's not a plan. We're doing it already, right? So those CI jobs, that's part of how we...
So in your deep dive session, you're going to give us more detail about it.
Yeah.
All right. How many devices in total? Is this something you can share?
I think 20, perhaps.
20 right now.
Yeah.
All right.
Yeah. But right, so consider that those are sort of the
big one.
IP and
Exactly.
MPLS routers, right? So I guess that's...
And I think the first question is related to our initial topic of the day today regarding, manual configs, syncs, probably how are you doing today? Or maybe are you thinking about changing the way considering what we learned this morning?
That remains to be discussed, I suppose. But I think it's... Basically, if you go back to that, like, I mean, if you looked at Tru's slides, right, you have these constellations, multiple controllers, multiple different things, right? And I mean, it's sort of, I think that's an organizational problem, if you will. You decide how you want to manage your network.
Yep.
In this case, you decide how you want to. Do you want multiple NSOs or multiple network controllers?
No.
No. And then you're sort of, so it becomes much clearer, right?
Yes.
I think there's a very natural long-term solution, which is that let's manage everything with NSO, right? Certainly today, we're not there because there are, like we said, we're doing service discovery for network internal infrastructure services, but there are lots of customers where it's not done yet, right? So we're going to have a long phase where you expect out-of-band changes to happen to that, right? But as we go along, hopefully we'll expand, and in that, it's very natural that the long-term solution is to let NSO manage it all, right?
All right. Again, fantastic. You want to say?
Yeah, of course. The final goal is that nobody touches the router. Everything is done through
Nobody
NSO.
touches the router.
Yeah.
That's our ideal.
Yeah.
All right.
You're fired.
So we got more questions, but you're going to be also, we got the break now. So if you find them, you can ask the questions and stop them to ask those questions, or we're going to try to answer it for the people online.